Hello, everyone. Welcome to this week's geometry video. Today, we are going to have an introduction to writing proofs. And the word proof is probably something that you've heard a lot in class recently because we've been talking about which triangle congruence criteria can prove that two triangles are congruent. But we've just been sort of giving one reason. We've been marking a diagram and just claiming why something is true. But when we write out a formal proof, basically, we are going to be following a flow of logical reasoning, right? So it is a formal triangle congruence proof because we're actually going to write out step by step how I know each piece of information to be true, right? If I'm proving something, it doesn't mean I just sort of have a hunch like, oh, I think this might be true, right? The whole reason that we want to prove things is so that we can tell people with 100% certainty that we are absolutely sure that our conclusion is true. And so this is a very valuable skill, both in geometry class and elsewhere, right? If you think about just logical thinking and a logical argument, just being able to convince someone that your opinion is right, if you're literally just having a conversation with them, something that I tend to do quite often because I like to be right. Don't know about y'all. But yeah, by learning how to logically think and how to support a logical argument, you will be able to prove with 100% certainty that something is in fact true. So, because these are triangle congruence proofs, we are still going to be using a lot of the knowledge that we've just talked about. And just as a review, we've learned 5 different triangle congruence criteria that can be used to prove triangles congruent. So these are totally going to be coming back to play as we learn triangle congruence proofs. But before we even step into the triangle congruence proofs, we're going to sort of start with the basics so that it's not as overwhelming and we can go back to the foundations and things that we're super confident in before we go and apply this to some of the more new knowledge that we have. So the first thing we're going to start with is actually an algebraic proof. And basically what we're going to do is we're going to solve an algebraic equation and we're going to list out step by step what is happening. And then we are going to explain why we were able to do that. And so we are going to do this in the format of a 2-column proof. And a 2-column proof is set up so that on the left side, you guys are going to be writing a series of statements. And on the right side, you're going to be listing your reasoning for why you can claim that statement to be true. Okay. So first up, I'm going to go ahead and I'm just going to rewrite the equation that I was just given. So 2 times x plus 4 is equal to 5x minus 1. This was told to me in the context of the problem, right? It said, describe every step you use to solve this equation. So I'm going to solve it, and I'm starting with this equation that's been given to me. So I'm going to say that the reason that I know this statement is true, 2x plus 4 equals 5x minus 1, that is true because it is given to me. And that is enough of an explanation. If the problem gives you this information, you are trusting that the problem is not lying to you, and so you know it is true just because it is simply given to you. So a very common reasoning that we're going to start proofs with is just saying that something was given to us. Now that we have that piece of information that's been given to us, I'm going to go ahead and go to the next step in solving. So if you were to approach this question, right, think about it, what would you do next to solve this equation? Well, there's actually a couple options. So one, you could go ahead and you could divide both sides by 2, okay, but that's going to leave us some fractions right away. So what I would assume most of you guys would want to do would be to go ahead and distribute that 2 and multiply it times that x and multiply it times that 4. Okay. And when you were to do that, that would give you this new equation of 2x plus 8 is equal to 5x minus 1. And nothing fancy, nothing new here. That is just basic algebra that you've learned before. But what is new is I'm going to give an explanation for why I could do that. Like, why could I rewrite that first writing of the equation? Why could I rewrite it that second way? Well, that is because of the distributive property. Right? And the distributive property tells me that if I have a number on the outside of parentheses, I can multiply it times each term inside the parentheses and get rid of the parentheses. Now I'm going to keep solving. in order to finally have x isolated at the end, I'm going to have to get all my variables onto one side of the equation. So what I'm going to do at this point is I would like to subtract 2x from both sides so that I can cancel out the 2x from the left side. And when I do that and then go to rewrite my equation, that leaves me with just 8 on the left side and 3x minus 1 on the right side. Now, I have to give a reason to justify why I was able to do that. And so if you're thinking about it, well, the reason I was able to subtract 2x from the left side was because I also subtracted 2x from the right side of the equation. I subtracted the same thing from both sides. And if both sides decrease by the same amount, both sides stay the same. What that's called is the subtraction property of equality. Right? It just says if I subtract from both sides stay the same. Okay? And so that is the reason that I can take that step. The next step that I'm going to want to do is I want to get all my constants on one side. So I'm going to go ahead and add 1 to both sides in order to get that 1 away from the right side and move it over to the left side. So on the left side, I will then have 9. And on the right side, I will be left with 3x. So 9 equals 3x. And then again, I have to think about why was I able to do that? Well, I added something to both sides. So similarly to in the last step, here I would just say that that is because of the addition property of equality, which, as it's written out here, right, that means that if I add things to both sides, the two sides stay equal. My last step in solving would be to divide both sides by 3, okay, to isolate the variable. And when I do that, I would get 3 is equal to x, or in other words, I could also write it as x is equal to 3. Some of you might prefer seeing it like that. And again, this is by definition, right? If I divide something to both sides stay equal. And so that is just called the division property of equality. So if you look here, you see a series of statements and a series of reasoning. For every statement I performed, I described why I knew that I could perform that step. Okay, and that is the key to being able to defend logical reasoning and prove that your conclusion is true. Like at the end here, you're not just claiming x is equal to 3, you are showing your worth mathematically and in words explaining why each step was possible. So, very, very important when we do proofs, we need to explain every step we do. We can't just do something for no reason. We need to list the reason, because if you have a gap in your reasoning, if there's one step and you can't explain why you were able to do that, then your argument is basically invalidated. It's no longer a proof. I can only claim that this is a proof that I'm proving something to be true if every single step along the way is justified. So that's one very important thing. Every single step you do needs a reason. The other thing is that order does matter. So what you do has to follow a logical order and progression. And if we look back at the prior example, that made a lot of sense with an algebraic proof because we have an order of operations that you have to follow, okay? Or when you're solving, you're essentially using the reverse order of operations. But there's a certain way in which you have to solve. So obviously you're going to solve in that order. But when we get to triangle congruence proofs and other proofs, just please keep in mind that you need to be doing things in an order that makes sense. You don't just list random statements and reasoning. One statement takes you to the next. So when I solved one step of the algebraic equation, the next step was based on the step above it. And that's what we're going to be doing when we learn about geometric proofs. So because of that first bullet point that says for every statement you need a reason, we are going to practice just listing the reasons that I can claim certain things are true. So we're just going to work through this one at a time. So look at example number 1. It says that given angle ABC is congruent to angle STP, the measure of angle ABC is equal to the measure of STP. So just to sort of break this down, I have a given statement. Oh, didn't mean to cross that out. That's supposed to be underlined. I have a given statement. And then I also have a conclusion. So given those two angles are congruent, I am concluding that the measure of the angles are equal to each other. Okay, please remember that little m, it means the measure of the angle. So you're talking about a number of degrees. Okay. Well, if two angles are congruent, yeah, like they're going to have the same measure as each other. And again, we don't really have to get super fancy here for a lot of this stuff. That is literally just by definition. What does congruent mean? The same size and shape. So yeah, it's going to be the same exact measure. So the reason I know that the measure is the same from congruence is by the definition of congruence. Right? Congruent essentially just means the same. So if they are congruent, they're going to have the same measures. That is how I am able to draw that conclusion. Moving on to number 2, again, I have a given and a conclusion. So given that the measure of angle RPT is 90 degrees, I'm concluding that angle RPT is a right angle. Well, how can I just assume RPT is a right angle because it's 90 degrees? Well, I'm not just assuming. That is literally the definition of a right angle, is that a right angle is 90 degrees. So I know that this is true by the definition of a right angle. So those two are very similar to each other just by definition. Let's look at 3. And this one isn't just by definition. This one's a little different. And so here it says that line segment RM is congruent to line segment RM. So, okay, something, an object, line segment RM, is congruent to itself. Oh, does that sound a little bit familiar? When we looked at triangles and we talked about a shared side between two triangles and how any object is congruent to itself, right? We talked about that a lot with little triangles, like something like this. And we said that this line in the middle, it's congruent to itself. And we called that the reflexive property, right? So RM is congruent to RM by the reflexive property, which just states that any object is congruent to itself. Okay. Moving on to number 4. Here we have given ST is equal to RV, then ST plus FM equals RV plus FM. So let's see, how am I changing from this original statement to my next one? Well, it appears that what's happening is I still have ST on the left side of this equation, but I'm also adding FM. And on the right side, I still have RV, but I'm also adding FM. So I can conclude this is true because I took the two sides, I left them the same, but I added the same thing to both sides. So this actually goes back to just the algebraic properties we were talking up above, which is just saying that if I add something to both sides, it stays the same. And once again, that is called the addition property of equality. This next one makes this claim. It says that angle STR, so I'm going to go ahead and draw that in. Okay, so angle STR, that's happening right there. So I know that the angle that I'm referring to is this angle right here, is congruent to angle UTV. So it didn't say that that was given to us, right? It wasn't like given angle STR is congruent to UTV. It said it's true. So I'm trying to figure out, how do I know that's true? It's not given to me. But I do know it's true because look at this diagram. We see how these two angles, they are happening at the intersection of two lines, and they are the angles across from each other. Again, we've talked about the triangle congruence criteria. This has come up a million times. And angles across from each other at intersecting lines are just called vertical angles. And we all know that vertical angles are congruent to each other. So I can claim that those two angles are congruent because they are vertical angles. And then last but not least from this section, number 6 says that triangle MAP is congruent to triangle SKY. It says, given that information, segment PM is congruent to segment YS. Well, how would I know that? Let me look. So segment PM, P is the third letter here, and then M is the first. And then my second triangle, oh, YS, Y is the third and S is the first. So we've talked about this before, and knowing, being able to tell that angles or sides are congruent just from looking at the triangle congruence statement. And that's basically because congruent or corresponding parts of congruent triangles, they are congruent to each other. Okay, this is something that's going to come up a lot as we do more and more of these formal proofs. It's jumping a little bit ahead right now, but this is actually abbreviated to something called CPCTC. Okay, and what that means is basically I'm just saying that corresponding parts of congruent triangles are congruent. Okay, so now that we are experts at giving reasonings, we are going to continue on. And now, given a statement, we are going to determine a conclusion. So this is us really getting into the meat of what proofs are. Again, we're still not doing lengthy 2-column formal proofs, but these are sort of like brief little proofs. So basically, I'm given information, and I'm trying to figure out what can I determine based on that information, right? So if I give you one piece of information, what can you gather? What inference can you make? Right? What else do you know is true because this information is given to you? So in this first one, number 7, it says, given NP is the bisector of angle MNO. So first of all, I want us to remember what the word bisect means. Remember that bisect means to cut in half. And in geometry, when I'm telling you that something is bisected and something is cut in half, pretty much always the reason I'm telling you that is to tell you that you are going to be left with 2 congruent parts. So let's look back again at this problem, and it says NP, so I'm just going to highlight NP real quick, is bisecting angle MNO. So then MNO. Okay, so that vertical line is, or the vertical line segment, is bisecting that angle at the top of this triangle, which means it's cutting it in half, and it's creating 2 congruent pieces. Both sides of that angle, right, both of those smaller angles are going to be congruent to each other. And so that's basically my conclusion, is I can conclude that those 2 angles are congruent to each other. So I'm going to name the first angle, the one on the left is MNP. And I'm going to say that I know for a fact that that is congruent to angle ONP because of the fact that the larger angle was bisected. Now let's look at number 8. It says, given that MR is perpendicular to GT. So let me just sketch out a picture real quick. I'm going to say MR is perpendicular to GT. Since they're perpendicular, I'm going to mark that little 90-degree angle there because that's what perpendicular means. Okay. Well, what exactly can I conclude from this? I sort of already hinted to it by drawing that in the diagram, right? I said perpendicular lines mean 90-degree angles. So anytime you draw perpendicular lines, you draw in that 90-degree angle right away. Okay. So basically, given this information, I know that segments MR and GT meet at 90-degree angles. And again, the reason I know that is because of the definition of perpendicular lines. Right? It's just what perpendicular lines are. Right, now let's look at number 9. Again, I think I'm going to draw a sketch of this to help me visualize. It says, given points D, E, and F are collinear. So what that means is these are 3 points, and they're all on the same line. So let's say I have D, E, and F. They're all on the same line. I'm going to try to draw a conclusion from this. Well, look here. I have DE. That's a little segment right here. We got a little segment. And then EF is another little segment right there. And if you look at those 2 combined, that would actually give us this bigger segment that goes the whole way from E to F, D to F, sorry. So what I would say here is that given all these points, they're on the same line. If I take the length of DE and I add it to the length of EF, that's going to give me that full length of DF. So moving on once again, we have here that angle RMS and angle FBT are a linear pair. Well, let's think about what exactly a linear pair is. Remember that a linear pair is basically two angles that are adjacent and they form a line, right? So there's two angles. So what I know here is since those two angles, I don't know the exact measure of each, but if they are forming a line together with the two of them, this full angle with both of them combined is going to be 180 degrees. So my conclusion here is going to be that the measure of angle RMS plus the measure of angle FBT is going to be 180 degrees. Again, that's just from the definition of a linear pair. Looking here at number 11, trying to figure out some conclusion I can draw from this one. I'm given that ZB is equal to LQ. So talking about ZB and LQ, well, if they're equal, they're the same. I could also say that they are congruent, right? I could mark that they're both congruent to each other. So that's the conclusion I'm going to make. I'm going to say that ZB is congruent to LQ. And that's just by the definition of congruence. If two things are equal, they're the same, so they're the same size, same shape, they're going to be congruent. Yeah. And then lastly here, we have a last given saying, given that the measure of angle 4 plus the measure of angle 6 is equal to 90 degrees. 90 degrees, two angles that add to 90 degrees. What could that be called? Oh, if I think back to the beginning of the year when we talked a lot about our geometry vocabulary, and remember that that means that, bleh. Okay, if I have two angles and they add to 90 degrees, that means that they are complementary angles. Okay, so angle 4, and I can write that out, and angle 6 are in fact complementary angles. Again, literally by the definition of complementary angles. So what we've learned so far and sort of talked about and what we're about to apply is that all proofs must always include both a statement and a reason. Right? So you're making a claim, that's what a statement is, you're claiming something to be true, and then you have to justify it by giving a reason. Because again, if you don't make a claim and justify it with a reason, then nobody's going to believe that what you're saying is true. You have to be able to back up what you're saying. And that is, again, the whole importance of being able to do proofs. So before we end this video, we're going to do one example of an actual full-length formal triangle congruence proof. And we're just going to work through this together. This is something you're going to have a ton more practice with and see another video on and have practice in class. But we are going to try one right now. And so basically when you do these proofs, you're going to have these two columns. One is to list a bunch of statements and the other is to give the reasoning or the justification for each statement. And then you'll notice at the beginning, you're basically going to be told some information that's given to you. And then based on that information, it's going to ask you to prove that some statement is true. Okay. And you're going to have to use that information and any other information you can draw from that in order to prove that this conclusion is true. You'll notice that the givens have already been written in as the first statement here. Typically, we do start triangle congruence proofs with the givens. You'll start at least with one given. Sometimes you can separate those, but we'll get into that more in class. But these two givens are already written as the statement. So I just have to justify how I know statement 1 is true. And those are literally copied directly from the given. So I'm just going to say that those are given. And then I somehow have to figure out, how do I get to this conclusion that triangle LNS is congruent to triangle WNK, right? It's what I was asked to prove. So that is basically my endpoint, right? I'm starting with the givens, and then I'm eventually going to get to that fact that these two triangles are congruent, but I have to prove it in between. So before I even try to write out a formal proof, I'm going to start with what I know. I'm going to approach the information given to me in the diagram, and I'm going to see if I can find a triangle congruence criteria that proves them congruent. That's what we've been doing for the past week or two. So here I'm given the information that N is the midpoint of LW, right? So if N is in the middle of L and W, that basically means each of those two separate segments are congruent. And that's actually already been marked on this diagram. That didn't even need to be done. That was just sort of nice of whoever created this, right? But had that not been marked, because N is the midpoint, I could go ahead and write those are congruent to each other. And then because N is the midpoint of SK, I also have these two pairs of segments that are congruent to each other. Okay. And then if I'm trying to figure out, can I prove these triangles congruent, having two pairs of congruent sides, that's not enough information. Is there anything else I can mark on this diagram just by looking at it? Why, yes, there is. Look, they meet at intersecting lines. So I also am going to know that the angles across from each other are congruent to each other. Okay. So if this was just one of the problems that you guys have been doing recently, you would look at this diagram, you would mark it as I just did, and then you could say that this is congruent by side angle side, right? Because we have two congruent pairs of sides, and the angle in between those two sides is also congruent. But what I'm doing is I'm writing this out in advance to sort of give me a game plan to map out the strategy that I'm going to use to finish out this proof. So basically, at the end, you are going to be using this triangle congruence criteria to prove the two triangles are congruent to each other. That's how you're going to know they are congruent, right? You're not going to randomly find angle, angle, side throughout writing explanations, right? It has to be what's given and what you found in the diagram. So I know that I'm going to prove congruence by side, angle, side. So personally, I'm just going to go ahead and already write that here, just to get it out of the way, because I know it's going to be true. But then I have to figure out, well, what exactly was that thinking that went on up here that allowed me to claim that these are congruent by side, angle, side, right? So it's thinking that you've been doing for all these past topics, but now we're applying it and writing it down in proofs. So remember, when I was reading the givens, I started marking things on the diagram, right? When I said N is the midpoint of LW, I said, oh, that means that both those smaller segments that it makes up, they're going to be congruent to each other because N is in the very middle. So both sides are going to be the same. Well, if both sides are the same, what I'm claiming is I'm saying that those two are congruent to each other. So Ln is congruent to Wn. Okay, my screen is like really broken in that place, so sorry if you can't see that. That's supposed to be a WN. And then the other thing that I sort of claimed from my givens was that N was the midpoint of SK. So again, when I said that, I was able to mark two things on the diagram. I could say that SN was congruent to KN. So in this same step, I'm going to claim that that is also true. I'm going to say that SN is congruent to KN. Now, how again did I know that was true? Well, I knew that's true because I was told that N was the midpoint. Okay, and I know that if something is in the middle, that means that the two sides are going to be the same as each other, right? And so this just comes from the definition of what a midpoint is, right? So I say the reason I could claim those sets of sides were congruent is because of the definition of a midpoint. So this is great. I've now already been able to justify why two pairs of sides were congruent. And I kind of like to sometimes mark that like I had a side and a side that I claimed were congruent, because this is the thing. If you are working through a triangle congruence proof and you're trying to claim that something is true from side, angle, side, somewhere along the way, through the statements and reasonings, you need to claim and justify that both those pairs of sides and a pair of angles are congruent. So all three of those things need to be ticked off by the time you get through the end of this proof. So I'm just making sure that I'm sort of double checking. And at this point, I have both claimed and justified the fact that I have two pairs of congruent sides. So the other thing I need to claim is that I have a set of congruent angles. Okay. And I was able to do that, right? When I did the diagram up here, I marked those as congruent. And so I'm going to go ahead and I'm going to make that claim. I'm going to say that angle LNS is congruent, that's not writing there, is congruent to angle WNK. And remember that the reason I was able to mark that on the diagram was because I know that those are vertical angles. Okay? And I also happen to know vertical angles are congruent. But because vertical angles are congruent, I can claim those two angles are congruent to each other. Okay? And at this point, I've claimed both pairs of sides are congruent, and I've claimed an angle is congruent. So I've justified the fact that in my diagram, I have side, angle, side. So at this point, I can go ahead and I write in this final conclusion that I'm proving triangle LNS is congruent to triangle WNK. And I am claiming that's true because of side, angle, side. Okay. So that is basically it for this video, but before we end, just to revisit this learning target and make sure that we did hit the objective for the day, remember that our goal was to use our knowledge of triangle congruence and congruent statements to begin to write formal congruence proofs. So we took that knowledge from before. We talked about how we would use things like side, 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 or side, angle, side, those triangle congruence criteria, and we were able to use those and apply them into a two-column proof in order to prove formally that two triangles were congruent. So this is just the start. Again, there's going to be a lot more practice with this, and proofs have all sorts of applications, but hopefully from this, you'll at least be exposed to that and be able to start using logical thinking to back up your arguments.